Welcome to the Deep Dive, where we take a monumental stack of research, the latest science, history, physiology, you name it, and distill it down into the most incredible insights just for you.
And today, we're talking about pure, unadulterated speed.
We really are. We're looking at the cheetah,
Yeah.
the undisputed land speed champion. I mean, we're talking bursts up to 104 kilometers per hour.
But it's not just speed for its own sake,
Yeah.
because there's this incredible paradox with the cheetah.
Okay, let's just get right into that. You have this animal that is built like a precision race car, just a masterpiece of evolution. And yet, it's also one of the most genetically fragile, most vulnerable big cats on the entire planet.
It's this spectacular athletic triumph on one hand and a genuine biological tragedy on the other.
Exactly. So our mission today, using sources that cover decades of research, from those early, really shocking genetic surveys in the 80s all the way to modern genome sequencing, is to get beyond the speed.
Right. We want to answer the 10 most curious questions about this animal. Its bizarre biology, its strange history with us humans, and its desperate fight for survival.
So let's start with the obvious, because the numbers are still just jaw-dropping. Question 1. How fast are they, really?
The top bursts that we can measure are usually between 93 and 104 kilometers per hour. So that's, 58 to 65 miles per hour.
Faster than you're allowed to drive in most cities. But you're right, the top speed isn't the whole story, is it?
No, not at all. It's the acceleration.
The acceleration is what sets them apart. I mean, we're talking 0 to 100 kilometers per hour in about 3.4 seconds.
Just think about that.
It's comparable to a high-performance supercar. But this one runs on muscle and bone.
An incredible internal engine.
Yeah.
And that leads us right to question 2. What physical adaptations make that possible?
Because it seems impossible.
Well, their entire design is what we call cursorial specialization. Every single part of them is built for running.
So you have the powerful hind limb muscles, of course, long limbs, a small light head.
A short snout to cut down on wind resistance. Even those black tear streaks you see might help reduce glare.
But the skeleton, that's the real secret weapon, right? Especially the spine.
Oh, the spine is unbelievable. It isn't rigid like ours. It's so flexible, it acts like a giant spring.
It just folds and extends with every single stride.
And that flexibility is what lets them extend their stride length to, up to 7 meters.
7 meters? That's insane.
It is. And unlike other cats, their claws don't fully retract.
So they're like permanent cleats.
Exactly. They just dig in for maximum traction, and then there's the tail. It's not just for show.
No, it's a counterbalance, like an anti-skid system for those high-speed turns. It keeps them from wiping out.
It's the ultimate specialization.
But of course, that kind of speed has to come at a price. Which brings us to question 3. If they're that fast, why can't they sustain it?
The cost is just too high. That burst is a full-on anaerobic effort. It's only sustainable for, about 30 seconds? Maybe 500 meters?
It just pushes their whole system into the red.
Completely. The chase leaves them totally exhausted, winded. Their body temperature can spike to dangerous, even lethal levels.
And here's the kicker. Even if they make the kill, they're too spent to eat.
Right. They need 10, sometimes 30 minutes just to recover, lying there, completely exposed, before they can even start feeding.
And that vulnerability, that shifts the whole picture, doesn't it? Which gets us to question 4. Is the cheetah really a top predator? Or are they just fragile fast food for the savanna heavyweights?
No, they're not built for a brawl. You look at their slender build, they can't go head-to-head with a lion or a leopard.
So success is all about the chase. If the chase fails, they just walk away.
And if a conflict is coming, they run away. Their kills get stolen all the time by what one source called bigger, nastier opportunists.
Lions, leopards, hyenas.
Even wild dogs. The cheetah's instinct is usually to surrender the kill immediately.
Because an injury would be a death sentence?
Exactly. Speed is their escape plan, not their weapon.
It sounds like a terrible way to live, constantly having your lunch money stolen. But the males figured something out, didn't they?
They did. While the females are solitary and pretty timid, the males often form these tight coalitions.
Little gangs of like 3 to 8 individuals.
And this is their cheat code. It gives them a huge advantage. They hunt together more successfully, they can take on slightly larger prey.
And crucially, they can actually stand up to scavengers and defend their meal.
Their social life is a direct response to that ecological pressure.
But if we look at their family life, the numbers on juvenile mortality are just heartbreaking. Why is it so high? That's question 5.
It's brutal. The females raise these huge litters, 4 cubs on average, sometimes up to 8, and they do it completely alone.
No help from the male or other females.
None. And you combine that solo parenting with the same predators that are stealing her food.
The numbers are staggering. In areas with lots of predators, over 80% of cubs might not make it to adulthood.
80%. They're lost to predation, mostly lions and hyenas raiding the dens, but also abandonment or starvation if the mother can't hunt successfully.
So those huge litters, it's a numbers game.
It's an evolutionary bet. Researchers think that's the adaptation. Have huge litters, and if you lose them, come back into heat very quickly. Basically breed fast to try and outrun that catastrophic mortality rate.
Okay, now we have to get to the biological mystery at the very heart of this. This is the core of the deep dive. Question 6. Why are all living cheetahs practically identical twins?
This discovery goes back to the 1980s. Genetic surveys found what they called an extreme paucity of genetic variability.
And when they say extreme, they mean it.
Oh, yeah. We're talking 90 to 99% less overall diversity than what you'd find in most other mammals. It's shocking.
And the test they did to prove it is the part that always gets me. They tried swapping skin grafts between unrelated cheetahs.
And the grafts were accepted. No rejection.
Which should be impossible.
It should be. That's a response you only see between, identical twins or immunological clones. The cheetah's immune systems literally couldn't tell the difference between their own skin and a total stranger's.
So that points to this alarming uniformity in something called the major histocompatibility complex, the MHC.
Right. The MHC genes are like your immune system's ID badge. They identify what's self and what's foreign.
But if everyone has the same ID badge,
then a virus that figures out how to beat one cheetah's immune system can beat them all. And this all traces back to at least 2 severe population bottlenecks.
the most recent one being that late Pleistocene mammal extinction, only about 11,000 or 12,000 years ago.
It almost wiped them off the map.
So that raises the biggest puzzle of all, question 7. How on earth did a species survive that? If they're so inbred, shouldn't they have died out thousands of years ago?
This is where the science gets really mind-bending. The leading theory is that the bottleneck was long enough ago that the most severe, the most deleterious mutations that came from the inbreeding were actually purged.
So the weakest individuals just died off quickly, leaving only the healthiest ones to reproduce.
Exactly. Natural selection was incredibly intense right after the bottleneck.
So the trauma, it actually perfected them. And it didn't just purge the bad genes, it locked in the super gene.
That's a great way to put it. Genomic analysis basically confirmed this. Researchers found 11 specific genes that were clearly selected for, all related to speed.
So what were they for?
5 for explosive muscle power, 4 for rapid metabolic turnover, and 2 for stress and recovery. The bottleneck accidentally fixed the genes that made them the ultimate sprinter.
So the conclusion from the research is that the inbreeding defects weren't what was holding them back in the wild, they were thriving.
Right, they thrived until we humans started taking away their habitat.
But that lack of genetic diversity still left some ticking time bombs, which is question 8. What are the visible, measurable consequences of this poor genome today?
Oh, they are numerous, and they are severe, especially in reproduction.
The male reproductive system is in crisis.
It's a disaster. Male cheetahs have a 10-fold reduction in sperm count compared to other healthy cats, and about 70 to 75% of their spermatozoa are malformed.
75%. And what's normal for, say, a domestic cat?
Maybe 25 to 30%. And we've even linked this to a specific gene substitution, one called AKAP4. It basically guarantees abnormal sperm across the entire species.
And then there's the immune system catastrophe you mentioned.
That lack of MHC diversity, it makes them hyper-susceptible to viruses.
They just have no genetic buffer.
None. A classic example was in 1983. A feline coronavirus outbreak hit a captive colony. Now, in domestic cats, this virus might have a 1% mortality rate.
And in the cheetahs.
100% of them got infected.
Yeah.
Within 3 years, 60% of them were dead.
That's unbelievable.
That is what happens when you're an immunological monoculture. One key fits every lock.
And they have other issues in captivity too, right? Like severe gastritis.
Yeah, from the Helicobacter bacteria. Wild cheetahs carry with no symptoms, but in captive ones, it causes this chronic, debilitating inflammation. It's another sign of a fragile system.
Okay, let's shift from genetics to history, because their relationship with humans is unique. Question 9. Were cheetahs really kept as pets?
Oh, absolutely. For thousands of years, they're famously easy to tame. They show, as one source put it, no hostility towards people.
They're just friendly.
They seem to be. And because of that, they've been status symbols and hunting companions since antiquity. We have depictions from Chauvet Cave that are like 30,000 years old.
Wow.
The ancient Egyptians kept them. But their use as hunting partners really peaked with nobility in the Arabian Peninsula, Persia, and India.
I read that the Mughal ruler Akbar the Great in the 16th century supposedly owned 9,000 cheetahs over his reign.
Can you imagine? The method they used was called coursing. The cheetah would be hooded to keep it calm, carried on horseback or in a cart.
And then released to chase down game like antelope. They were prized for the chase, not for the kill itself.
That's right. And then they'd be rewarded with a piece of the kill.
So this historical obsession, this leads directly to question 10. If they were so prized, why couldn't people breed them in captivity?
That's the million-dollar question. I mean, if Akbar owned 9,000 cheetahs, you'd think he'd have a cheetah farm by accident.
But his records say only one litter was ever produced in his entire 49-year reign.
It baffled people for centuries. We now know their reproductive biology is incredibly complex.
For one, females have what's called asymmetric reproductive aging.
Meaning if they don't breed when they're young, their fertility just plummets. And in captivity, they often don't show obvious signs that they're ready to mate, so the timing is almost impossible to get right.
And their wild strategy is something else entirely.
It is. In the wild, females practice polyandry.
Mating with multiple males.
Right. And this seems to do two things. First, it maximizes the genetic diversity in the litter, which is critical for a species like this. And second, it might confuse paternity and reduce the chance of males in the area killing the cubs.
So it's this incredibly complex mix of behavior and biology that you just can't replicate in a zoo.
Exactly. At least not until we really understood what was going on.
So let's put all these pieces together. What does this all mean?
It means the cheetah is the ultimate specialist. It runs the fastest race on Earth because a near-extinction event 12,000 years ago paradoxically perfected its genome for speed.
But that same event, that hyperspecialization, left it with almost no genetic flexibility. It made them incredibly vulnerable to disease, to competition, to everything, really.
And today, the global population is estimated at just over 6,500 individuals. They're officially listed as vulnerable.
And the threats are all human: habitat loss, conflict with farmers, the illegal pet trade.
But the great news is that all this genetic data is now informing conservation. We're getting much better at captive breeding now that we understand their complex needs.
And there are these amazing, ambitious projects, like the plan to restore African cheetahs to India, where they went extinct.
That's right. And that's moving forward specifically because genetic data shows the split between African and Asian populations is shallow enough that it can work.
It's a phenomenal story of a species that literally ran itself out of a cataclysm. It locked the supergene.
It did.
So the final provocative thought for you to chew on is this. The cheetah's ancestors survived a global extinction event by becoming the absolute master of speed. But today, their survival depends less on how fast they can run and far more on how quickly we can manage their fragile genetics and protect the diminishing world they need to run in.